give you a talk today on publishing your results. So this is my plan. I have a brief exhortation that may or may not be for you, depending on how much experience you have with the publishing process already. Then hints for successful writing, some thoughts about paper structure, a little bit of my own account as an associate editor of Remote Sensing of Environment. Not nearly as influential a publication as Nature, as we heard about last week, but a more specialized journal that most of us will have more interaction with than Nature. And finally, the sublime pleasures of manuscript reviewing. So this first 3-minute section is a brief exhortation, and this was actually something that I practiced recently. I was taking John Townsend's advice to heart to practice presentation skills, because that's a whole different set of skills than what we've been practicing the last 2 weeks. So some of you are pretty early in your graduate career. You think about the time that stretches out in front of you and you think, I don't have to write up my dissertation for quite some time yet. I'm still good. I'm here to tell you today to write early and write often. Don't fall into the delusion that so many graduate students do, that after a few years of working hard, the data are all collected, the experiments are run, the results are there, your data analysis is pretty much done. I'm done with my research, I just need to write it up. I've heard that a lot of times, actually, from a lot of different students, and I count myself among them. So I'm saying, do as I say, not as I did. But the graduate students can grow old this way, because when you get to that point, it's daunting. So why right now? Because just like playing the piano, practice helps. Think intro, methods, results, discussion, conclusions, the basic structure of all scientific stories. Before you've done much experimental work at all, you can start writing your intro and crystallizing your ideas. You can write the most important ideas down. What are the key ideas of the paper? What do you want to find out? Why is this a new idea? And that last, the new idea, to prove it's a new idea, you're going to need a logical background section in your intro. So to prepare for this, write down the key ideas of papers as you read them. Not later, but now. So use tools, use Mendeley. There are lots of other tools around that can help you do this. For methods, refine your experimental design by writing it and rewriting it. Because other people will need to reproduce your methods, detail each step. You can always cut later. But trust me, you don't want to try reconstructing things later, because those steps will have faded by then. So writing early and often gives you the opportunity for written feedback from your advisors and other helpful people around. And writing the results, discussion, and conclusions will be much easier at that point. So instead of facing the horrifying prospect of writing a tome after all your work is behind you, you'll have a substantial portion written up, and you can be like this young man who says, I've been writing all along, my dissertation's nearly done. So that's my brief exhortation, and hopefully it's motivating. So now I'm going to switch from PowerPoint to Keynote, which is a very nice tool for putting together presentations. Gives you a lot more help than PowerPoint does. And this is a little bit more relaxed. I'd like to get a little bit of discussion in this part of the talk. So, hints on successful writing. As you've just heard, write up the intro and methods as you go. It's a lot easier to revise than to face the blank page. I can't stress this enough. As a reviewer and as an editor, it is so much more difficult to review a paper that hasn't been thoroughly copy edited. Use good grammar. If you have trouble with this, ask for help. There are professional editors around. There are helpful colleagues who might be able to spare some time to really work with you on this. The proportion of papers that we get these days that are not grammatically well put together it's climbing, and it really does create obstacles to the reviewer and reduces your chance of getting your paper published. Be careful with problematic terms, and I'm going to cover this in the next slide. This has a lot to do with with terms that have come to mean something very specific in a technical field, but which also have general meanings or connotations in the popular imagination, or even from early school days. And that kind of confusion creates a lot of problems. So I'm going to share with you some of my favorite problematic terms, and you probably have some others that you'd like to share with me. Use tools to manage citations of previous work, and that was a point I made in my exhortation. I'm going to show you Mendeley. How many people have used Mendeley or heard of it? One person. Okay, so maybe I'll excite you a little bit with that tool. I was excited. I haven't used it enough yet, but it promises to be very helpful in both the research phase and in the publication phase. And then this almost goes without saying, but a lot of people don't seem to do this. There are instructions to authors with every journal. Read them carefully. Same thing with writing proposals. Read the proposal call very carefully, because somebody went to the trouble of writing those down and is thinking that you're going to actually follow those instructions. So it's good to meet them in the middle by reading the instructions and following them. So, problematic terms. Scale. What does scale mean? Can anybody give me a definition of the word? Any definition. What does it mean? Sorry? The extent. The extent of what you're talking about. Mm-hmm.
Also used for the resolution. Small scale, large scale, grid spacing.
Grid spacing and resolution. So is that temporal resolution or spatial resolution?
I was thinking spatial, but it could also be referred to over a long time scale or shorter time scale.
Mm-hmm.
It could also be spectral in that sense.
Mm-hmm. Yeah, I haven't seen it, but in that sense, but it probably could be spectral as well. Any other definitions? The geographers among us, or the cartographers among us? A small scale map has a large extent and full resolution.
Yeah.
So this I find to be a very problematic term, and when I was looking into this a while back, in some papers I couldn't actually figure out by context what was meant by scale. And in a lot of cases, the word scale is meant in one context in the beginning of the paper, in another context in the middle of the paper, and yet another context at the end of the paper. So that's one of those problematic terms, I would say. And I really appreciate it when people if it's going to be used in a general layperson sense, maybe that's appropriate and everybody understands, but when you're trying to talk about something specific, use the specific term. Validation. What does that mean? Verifying the research? What does that mean? If it's right, so how can you tell whether it's right?
Bring the generally believe in, bring the general right sources which he believed in, like general.
Anybody else have some ideas? Validation?
I always think of assessing performance of a model to an independent data set.
So looking at derived estimate compared to ground validation and comparing them with R squared, with mean squared error, and some sort of statistical assessment of accuracy.
So validation, validation is a fairly general term, and you have to be a little bit careful with it because your reference data or your ground truth or your independent data set may or may not be any more valid than what you're trying to compare it to. Uncertainty. What does that mean? I have to ask Jared because I know that Jared mentioned uncertainty in the beginning of last week about his work.
I think from a statistical standpoint of some kind of interval of the confidence of your result. Yeah.
So uncertainty certainly has a very, everybody knows what it means, but in a statistical sense it might have a very specific meaning. It may be applied to a particular model or a particular metric that comes out of a model that's supposed to represent our knowledge about something. So I most often see it in a generic sense, and then I wonder, well, what is the specific metric that's being used and how is that defined? So maybe as a problematic term, it's when it's really being used generally, but in the paper it seems to be applied specifically, but yet you don't quite know what specific definition is being used. So I urge you to spell it out. Value judgments. Our model was good. Our model was better. Our method worked well. Our approach was excellent. I know that I've been cautioned to try not to apply value judgments in scientific papers, but simply to report the quantitative results and comparisons, larger, smaller, because we all want to be good scientists and do better, but those terms don't have they don't really have absolute meaning, whereas quantitative comparisons do. This is probably one of my favorites, and Evan probably can relate to this, estimation versus prediction. In a statistical sense, these two words have technical meaning, that you estimate parameters and you predict variable values. But in geosciences in general, that is not the case, that you can estimate values of variables and parameters kind of equal the same thing as variables. So once that happens, though, you have to wonder if uncertainty models are being applied at all or appropriately, because parametric uncertainty is different than variable uncertainty. This one I learned from experience with another statistician who said, well, again in geoscience, we typically use the word sample to refer to, say, one plot or 1 cubic centimeter or one of the units that actually composes our sample. So we say, I collected a bunch of samples, but a statistician would say, no, you collected a sample of the population. So that one, I would say, is less problematic these days, but just be aware that to a statistician who's thinking about how are you representing your population, what is your population, how are you sampling it, what is your sampling unit, how big is it, how does it relate to the unit that you're really interested in, that can be an issue. And finally, for now, cross-validation. Now, cross-validation has a very specific meaning, a very specific technique. But I've run into a lot of papers in the last several years that have claimed to do cross-validation with just ordinary regression. And I've tried and tried. I've asked statisticians to try to tell me, well, what are these people doing? I'm not quite sure. How can you throw away some of your values and refit the model, and then throw away another set of values, refit the model? What model are you going to end up with at the end? I'm not really sure. So maybe you guys can explain this to me, but if I see cross-validation in a remote sensing paper, it raises red flags for me. Anybody think of other problematic terms that they've run into, things that puzzle them?
My guess is one of the things I get cautioned on frequently is the use of colloquialisms. Where I'll use a turn of phrase that symbolically illustrates what I'm trying to talk about, and then it falls on people who haven't heard that phrase or something to that effect, where you're saying, wait, what are you talking about? So I've had to really rein that in as a writer.
Yeah, in scientific publications, colloquialisms are not usually used, although for colloquialisms that the majority understand, it actually can improve the ability to read the paper, because it just gives us a sense of, but it is for an international audience, so.
I have one thing that right now more and more people are using one standard deviation to quantify the model uncertainty, and rather other people use two standard deviation to quantify the uncertainty. So that could be a problem.
Definitely.
Right now.
Yeah, and it seems like there's a community. There are two communities of practice at least. That the one standard deviation folks and the two standard deviation, or even three. In 7 Minutes of Terror, they're probably working with 3 standard deviations because they want to be very conservative.
Yeah, even for the variables that are non-normal, following normal distribution, they're still using standard deviation to quantify the uncertainty. So I'm not sure if it's gonna work.
Right, and the other thing is that often they don't say. They say uncertainty, but they don't say whether they're referring to 1 or 2 or 3 sigma. I think that engineers tend to learn 2 sigma in school, and geoscientists tend to learn 1 sigma in school, and so that gets carried through. But since we're all talking to each other these days, we have to be a little bit more specific. So great, thanks. I think I'm going to move on, but that's just to raise some consciousness about some problematic terms. I wrote a paper. This is the paper that in my publishing career that's gotten cited the most. For some reason, I just love these word clouds. So I made a word cloud out of that paper, and so you can see what it's about at a glance without having to struggle through the abstract. It's a balanced view of scale and spatial statistical analysis. So use tools to manage citations of previous work. Let me get out of the presentation for a moment and just go over to Mendeley. So Mendeley Desktop. This is a free tool. It's one of these cloud tools that are growing in popularity these days. It allows you to put your literature database on a cloud somewhere, and it allows you to manage your references and mark them up. So this is an example. This is my Mendeley desktop as far as I've gotten, and what the neatest thing is you can take a PDF off the desktop and drag it in here, and it takes out the author's title, journal, volume, pages. So you can, if you have the PDF on your desktop, you drag it in and it points to it, and you move it around on your desktop, it still knows where it is. So it's a really nice way of organizing your literature. Also, you can choose a citation style. So say you're preparing for remote sensing environment, and you can pull in the description of the references format. I'm going to choose this one for now and just demonstrate that you can say, take this one, Towards a Coherent Philosophy for Modeling the Environment by Keith Bevan. And let's see, I'm not too fast with this, but view as citations. Oh wait, oh that, so you can see that it puts all the citations in the format right there, and you can export it that way. So it's a really nice tool for integrating all of these functions. Also for markup, take a look at the notes. So I can open the PDF and highlight sections that are relevant. So I highlighted something down here and make a little note, and then you can list the notes and do searches on them. So it's a way of really collecting the points that you're going to want to make in your methods section or results or discussion, and be able to find them again. So, and then you can you sync with the cloud, which is storing this literature library elsewhere. So if your computer goes down, you haven't lost your bibliographic database. And what's more is you can share with colleagues. So if you go to the web, there's a Mendeley desktop, Mendeley on the web. So I have to log in. And you can have people that you are connected with and share references with them, and establish groups of researchers. So there are 48,000 public groups already. So I only have one contact so far because Michal, who's in my building, and I talked about it one day, and we got together. So anyway, for me, this is a really exciting tool, and it would be nice to jump on it and use it. Okay, going back to slides. Okay, so those are some hints, a few hints on paper structure. I've talked about, I mentioned the intro, methods, results, discussion, conclusion, structure. That's not going to go away anytime soon, so don't get creative on that one. Just follow it. Putting your rationale for why you're doing the thing and the introduction is critical to attaining reviewer acceptance. There are lots of papers that don't do this, believe it or not. Don't simply say, this is what we did, but why this experiment is important in the intro. For the most part, your paper won't be accepted if it's just a recipe of what you did. You have to give it meaning. So this is a sort of a discussion question. What makes a modeling paper publishable? People have some ideas on that from what they've learned in their graduate career so far. What do you think, Rama? What do you think makes a modeling paper publishable?
It sheds new light on something about the system that we didn't know before, which is rare as far as I'm concerned, because most modeling studies are kind of a ho-hum. But occasionally, you apply a model that is not intended for, and I think that's what is really interesting. But you don't really see a lot of those studies, because modelers who build models, they're so stuck in their way of thinking, they cannot think outside the way they build the model. So most good modeling studies come from people who have nothing to do with the model, because they're not constrained by what the model can and cannot do. Mm-hmm. And so they're applying and they're trying to address something that they think the model should be able to do. Mm-hmm. And occasionally you get a really good insight. And I'll give you one example. People have been doing this land surface modeling for so long. Only until about 1995, and Ines Fung and her grad student found out that, gee, if I change the routing depth from 1 meter to 10 meters, everything changes. But a modeler who built the model, he would never do that.
Because
he chose 1 meter, so he thinks that's the appropriate thing to do.
Choosing the value with a notion that that's probably the most realistic value.
That's right. From his own experience, there. Mm-hmm. But when he thought, wow, let me change the routing depth, because, you see trees growing all over the place, and it's in rocks everywhere. Mm-hmm. And when she changed it to like 10 meters, for example, yeah, all the phenological cycles were different, and everything changed, just by changing that one parameter. And I think all the modeling studies that we read about, everything is going to change. You look at the CME5, the climate models and all these things. As the time goes by, what we thought was the best science, may not hold up. Like another example, CME3, when, probably, and everybody thought Amazon is going to burn up and all that stuff due to drought. Because it's going to change. But again, with the CME5, it doesn't hold up. So it's things like that. You change a few parameters, everything changes. Mm-hmm. I think those are probably the most important studies that come out of modeling. Mm-hmm. Not so much how well you can reproduce, what you observe. A lot of times people use that as a benchmark, how well my model captures my observations. Mm-hmm. But most likely you already know you tweaked everything to fit those observations. Mm-hmm. But it's really the off-the-wall questions that I think that are most interesting from modeling. And that's what should be published. But they're difficult to publish, because you're doing something that, people don't think, about it.
Yeah, and another kind of modeling study is the one that says, here's a new model, and here's how I built it, and here are the assumptions I made, and here are the parameterizations I did, Um, and that's hard to publish too, because people say, do we really need a new model?
Yes.
Why
Yeah.
this one? Why
Yeah.
is this one different than the
Yeah.
others?
Yeah.
So both face, well, critical reviewer audience, which is typical for all papers really,
But I think, I remember maybe 20 years ago, modeling was really big. Everybody was trying to build a model. But I think we learned in the last 20 years that, we kind of beat that to death. We really need more observations before we can improve the models or build new models. Yeah. And also in the community, what happens is, let's say we're all modelers and we have different models. Okay, that's how we start. And then, with time, we're all converging. And I look at your model and say, yeah, she does actually this part really well. I'm going to take that. And then I'm going to take this from him. And then everybody's doing the same thing. So you can iterate to pretty much like one model. Even though we're all running different models in name, but they're all doing the same thing.
Yeah. The other side of that, though, is a lot of the ensemble modeling studies are finding great variance in the results
Yeah, that's
for
true.
some variables.
Yeah. But I think talking to Steve, in the IPCC, there's one model that that really drops down in the future.
Yeah.
And I don't remember whose it was.
I can't remember.
But he believed that it should have never been included in the first place.
Yeah.
So
Because it didn't match, well, it matched observations, recent observations, but
I don't
the
think it was
extrapolation-
even matching recent observations. But see, that's that. When you're trying to satisfy the community. Oh, we should include all the models. If you take this out, people will say, why did you take that out? So let's throw everything in there. And then you see this huge spread, but you're not going to convince anybody with that.
Yeah, so this is a this question leads to a lot of other issues, and there's no single answer to this, but it's food for thought. Different people have different opinions.
Yeah,
About
but I think if you want to do modeling, though, you should never really focus on how well the model is doing. I don't think that should be the real motivation. It's really about, looking at connections between things that you haven't thought about. Like, you're looking at Congo Basin. It's really interesting because, how is it connected to the South American, stuff like that we don't think about normally.
The next discussion topic is reproducibility in the methods. Is it possible? Well, science is based on reproducibility. A lot of paper, it's probably, in the case of complex models, it's not even possible to describe the methods such that somebody could reproduce the methods simply by reading the paper. So these days we're getting into promoting reproducibility using code archives and documentation of codes and social networking, things like that. But this is one of the very difficult things about our field as well as others, is how to write a scientific paper that has reproducible methods. You should always strive for it, even if you can't achieve it. Methods for comparing simulated versus observed values. I just want to put a plug in for not only reporting R squared. R squared between simulated and observed is not that relevant. You really want the simulated versus observed to line up on the one-to-one line. If it's on some other line, what does that mean? What is your model actually doing? It's so the supreme method for summarizing the comparison is the Taylor diagram, which comes out of climate science, and so the climate scientists among you are probably familiar with this. And if you're outside that or haven't run across the Taylor diagram, it's a really beautiful way of summarizing many of the things that are going on between simulated and observed, or simulated versus simulated, or comparing multiple data sets. And I'm not going to explain this here, but it's a really clever tool. I'd love to see more of it in Pierce. So now I'm going to just switch gears a little bit and talk about one journal, Remote Sensing Environment. Many of you might be interested in publishing in this journal. It's one of the oldest remote sensing journals, starting in 1969. Marv Bauer, our editor-in-chief, has been in that seat since 1980. And he's an amazing dynamo. He's really run the show and kept the quality of the journal very high, and in fact increasing. That our current impact factor is 4.5. As an overall measure of journal quality, it has its problems, but people use it anyway. There are 1,000 submissions a year, so it's somewhat competitive, since 70% of those are rejected, either right away or ultimately. But that's one way quality is kept high, is the bar is set somewhat high in remote sensing environment. The aims and scope are very general, just results on theory, science, applications, and technology of remote sensing of Earth resources and environment. So it's a very large remit: terrestrial, oceanic, and atmospheric sensing, biophysical and quantitative approaches to remote sensing at local to global scales. There's the scale word again. So this is local to global extent. I've reviewed for this journal for a long time, so this is just my graph of my reviews. Most of them are either revise or reject. Very few are accepted right away. Actually, no, I've never accepted one as is, and that's typical of reviewers for this journal and others. Get a scientist on something, and he or she will always find something wrong with it. So we always strive for 3 reviewers per paper, sometimes 4. Occasionally we'll get away with 2. And just like Mike talked about with Nature, the editors are the ones who make the decision. It's not a democratic decision across the reviewers. There's interpretation on the part of editors as to what information the reviewers give us, as well as our own views of the papers. It takes, right now it's taking about 4 or 5 months to review a paper, and after acceptance, about 6 weeks to publication. So that represents, as these kinds of journals go, pretty rapid turnaround. So, before I go on, any questions about remote sensing of environment? The sublime pleasures of manuscript reviewing. I borrowed this title from a talk that I heard at AGU last December, by an editor of another journal who was reminding people, exhorting people, another exhortation: if you're going to publish, you really got to review. It's a reciprocal deal. You can't really get one without the other. However, it is hard to get reviewers. I can now say that with a lot of emphasis, since I'm doing it all the time, trying to lining up reviewers for papers. And here are the reasons that I see that reviewers decline to review. The abstract is so bad, I just don't want to struggle through the rest of the paper. I don't really think very highly of that author. I don't really think that highly of that journal. I don't have enough time to do it. I'm too busy. I get too many review requests. It's not my area of expertise, or I have a conflict of interest. I think that pretty much captures the reasons for not reviewing. So I want to put a little doubt in your mind about some of these. The abstract is so bad I don't want to struggle through the rest. Well, you've already invested some time in reading the abstract. And if you really think it's that bad, spell out why. And maybe skim the rest of the paper and say, well, I see some other problems, but right away I just don't see that this can be a good study if it's not expressed well in the abstract. So take a little more time and write that up and submit your review.
Can I ask a question?
Sure.
Before we go? So, is there an initial screening for these before you send them out before you request reviewers?
I screen them, and I'm pretty sure the other associate editors screen them too.
But you get comments like that, the abstract is so bad?
Mm-hmm.
Interesting.
Yeah, because people don't always agree.
What fraction of the manuscripts are not even sent out for review?
For remote sensing of environment, I talked with Marv's kind of executive administrator, Betty, the other day, and she actually didn't have a good handle on that number. I don't know. I don't tend to see those. Marv is quite a screener for remote sensitive environment. So the statistics I showed for myself show that I don't do a whole lot of not appropriate for RSE, so the associate editors get screened a little bit from that. But I think I'm going to be doing more of that because 1,000 papers, that's a lot of papers.
Yeah, but can you guys actually put some restrictions on, like, if you want to submit a paper to this journal, you have to go through, you have to watch this video, or you have to do something like what you're doing now.
Well, the thing is that writing in good English is also a requirement, and there are lots of great videos out there to watch about English as a second language, health, and
Sorry about that.
lots of schooling throughout your career on writing well, but it doesn't mean that
Because
people,
I think now as it is now, it's wide open. Anybody can submit a manuscript.
Mhm.
But in some ways it's good because everybody has an opportunity to submit something. But it also overwhelms the system, right?
the system is straining.
Yeah.
I definitely think the system is straining in our field and probably in other fields too.
No, I'm sure it's the same thing. Yeah. But like when I get a review request, I don't even read the abstract because, like you said, once I read the abstract, maybe I'll be tempted to do it. Yeah. So I don't know how you deal with that issue of too many papers.
I don't know the solution either. I mean, setting another bar of entry is one way of doing it, but the thing is that has implications for graduate programs as well, because graduate programs are set up to train people to publish, and they, in fact, in order to get their degrees, often have to write papers that are publishable. So they're not even going to be reviewed by their outside their university unless they have that requirement.
Yeah, maybe it's not the right time, to have philosophical discussion, but at some point, I want to get back to this of a completely new way of publishing, because when you publish a paper, it's really based on 2 or 3 people's opinion. But now, we can have way more people actually weigh in on the quality of the paper.
If people read them.
Well, but I can say the same thing now. When I get a manuscript, you think that I read it, but I could actually do a cursory look, and in 5 minutes I can send something back.
Well, what Mike was saying about what nature does, remote sensing of environment does as well. The reviewers, we rate the reviewers and the review itself, and over time look at that and based on that decide who to send papers out to. So so reviewers are getting rated at the same time as the papers are getting rated. Everybody's rated.
All this brings to mind a discussion I'd had at Virginia Tech. I'd heard the idea raised that kind of a possible solution to both of the issues at once would be to charge a nominal fee to anybody trying to submit a publication, which would at once cause kind of a holdup on the side of the submitters because they're not going to want to just pay money to keep throwing out junk papers, but at the same time also use that fee to compensate the reviewers for their time in some sense, and therefore encourage the reviewers' quality as well. You know, as the reviewers get rated, the ones who have high quality get consistent reviewing assignments, and it gives them an extra motivation to do a good job for that. And there's a potential for a world of conflicts of interest in that, but the idea was very interesting when I heard it. I was wondering if you had any thoughts about that kind of an approach.
Well, the open access publishing uses a fee model for the author as opposed to a fee model for the reader. And as long as that fee is obtainable by most researchers, by 99% of the researchers, that seems somewhat appealing. But there is, I think, scientists, the spirit of science is a little bit against the idea of monetizing these things. As we've seen in the biomedical field, money can contaminate the process. So I don't have solutions, but another effort that remote sensing of environment has made is to have each paper even more of a summary than the abstract. So the three or four main findings are the highlights, and they're actually listed on the webpage with the paper. Those actually that I've seen have been written more poorly than the abstracts and the text. So since that's going to be the thing probably that more eyeballs will be on, it probably behooves you to work hard on crystallizing your ideas and writing succinct reasons why it's worth reading this paper.
Yeah, but in general, though, you'll notice in your own career that just because you publish a paper in Nature or Science or whatever, it doesn't mean that people are going to cite it a lot. It's really, there are many papers in Science or Nature that just don't get cited. So ultimately, it is really a good idea. It doesn't matter where you publish. So you have, papers in JGR, in remote sensing, and I was looking at Tucker's paper, was published in photogrammetric engineering. So one of the most highly cited papers.
Right, and that's why the impact factor as a way of making a decision on which journal to publish in is not necessarily the most important one. In fact, might be quite low for an individual to make that decision. But then the other question is, how do people find out about your paper if they're not reading photogrammetric engineering?
Nowadays I think there are a lot of ways. But in the end, though, you should look at science just like any other business, as far as I'm concerned. You should really address a problem that the community wants you to address. If you think, you can do whatever the hell you want and want to publish a paper, the community thinks, well, it's not what we need.
And just to put a little counterpoint into that, since we're at opposite sides of the table today, I'll say that that some creative ideas and kind of renegade things that were early on rejected, but later on became very interesting and cited much later on, is the way that science moves forward sometimes.
Sure, I think there are always renegades, that they will try to actually push their ideas and all, but you'll be way more successful in doing what the community thinks are useful and needs, rather than you know, pushing your own agenda. You can do that, as you get older, establish in the community, but I don't think you can actually succeed, with that when you're young. So the best way to establish yourself is to really address, what are the loose ends, in a theory, in the observations and all, and then slowly, step up to a more and more complicated ideas and things. And I think I see a lot of youngsters, they want to publish in Science and Nature right off the bat, as soon as you start your graduate student, because they think that's how you get notoriety and clients and all that stuff. But it's hard. Yeah.
I was lucky enough to have my name on a science paper as my first publication, but that was just because I was an intern with someone who was generous with authorship. I did some modeling for an air pollution modeler, and he published his work in Science. And so that's on my extended CV, that's the first citation, but it hasn't been cited much. And this paper I mentioned earlier in ecography, which most people haven't heard of, as a journal, has been cited 350 times. So there's a case in point now. So I want to conclude now by saying everybody has limited resources, limited time, and limited attention, and a lot of different commitments. So it's up to you to balance all of these effectively, but just take your reviewing commitment seriously and balance that along with everything else, because if you're submitting papers, then you also want to give as well as receive. Laura.
I just have a question. Is there any link at RSE between reviewing and authorship? Because when you review, you're encouraged to submit your papers to this journal kind of a thing. If you have, I have no idea how this reviewing ranking goes, but if you just have a really good sort of, relationship with the journal, would you be less likely to be have your papers dismissed without review or anything like that, or is there no connection?
I think there probably is an unspoken and maybe even unconscious connection, in the sense that if one of the editors reads a careful, well thought out review, they're going to receive it, and if they remember your name from that and see a paper from you, they'll be more likely to pay attention to it and say, oh, this is probably going to be a good paper because that person showed good, rigorous thinking in her review. Right. But there's nothing, there aren't any guarantees. Right. It's just the impressions that you make through your reviews are going to have, they're going to benefit you if they're good, act to your disadvantage if they're not. So I think Nick Coops, who's an editor on another journal, gave some rule of thumb for how many reviews you do per paper that you submit, and so maybe at the very least 1-to-1, if not 1-to.
But that's where I like what he was talking about. People should have a choice. They can contribute, by reviewing the papers or paying the publish. So, let's say if you review 10 papers, for that service that you provide to the journal, then maybe you get to publish a paper for free. So
You mean unreviewed, Robert?
No. You get to submit, but you don't have to pay. You don't have to pay to publish it.
You don't have to pay the page charges or whatever?
Yeah.
Oh, that's an interesting idea.
Because you have to figure out a way to motivate people to do these things. We are past the stage where we used to think of this as a community service. Because when you get a request every day, that's not service. It's almost like a job.
Yeah.
Well, there's an intrinsic reward in doing community service, and some people are motivated.
It depends on what is valued, in your career. If I say, oh, I reviewed 1,000 papers, you think anybody would give me a medal?
Well, it depends on whether metal is going to truly satisfy you.
That's what I'm saying, so we have to look at what the community values and how to promote. You can't have independent metrics from what is valued in the community.
When you see, I've seen on CVs, people mention that I've reviewed in this journal, this journal. What do you think? Is that something that's of value on the CV? I mean, that's another way to look, I guess, at reviewing. Is it something that I can show others that I've done a diversity or specific field of review?
Yeah, I think it's additional information about your expertise. Yeah.
Do you have a sense of what proportion of reviewers are graduate students versus faculty versus government scientists? Or
For me, there's a very low proportion of graduate students as reviewers. If I send out, if a person gets an invitation, they always have the option of passing the review on to one of their graduate students, in which case they're encouraged to say, to tell the editor, that's what I'm doing. And that's a really great practice, because then the person who's invited knows who the graduate students are who could benefit from that practice, and then they get a little bit of extra mentoring before the review goes back.
I think if you have equal weight, let's say we value publications, publishing, but we should have equal value in the number of reviews we do. So then you motivate people just as much as publishing papers.
Yes, if all of the tenure committees and promotion boards really did value that, that would be an excellent thing.
It seems like the whole thing is just a function of scale. It's kind of like the big data issue now. Reviewing a paper, you can kind of analogize with taking a penny or leaving a penny in one of the little take a penny, leave a penny jars at the grocery store. It's not a problem to put a penny in here and there, but when you start finding yourself constantly asked to put in a penny over and over and over, it's the scale change that suddenly, and I'm using the word scale, but it's that scale change that kind of produces a change in the way you really think about that. And that is where you get into those differences in what drives somebody internally to motivate. So maybe kind of like with big data, just a new framework for thinking about all this is really what's called. I don't know, I'm just speculating.
Well, with that, I think we'll close this portion of the schedule formally. And thanks for participating in the discussion.